Hello friends, in today's question, a stationary horizontal disk is free to rotate about its axis. When a torque is applied on it, its kinetic energy as a function of theta, where theta is angle by which it is rotated, is given as k theta square. If its moment of inertia is I, then the angular acceleration of the disk is. So we are given a disk, horizontal disk, which is free to rotate, and its kinetic energy is given as a function of theta. So we know that rotational kinetic energy is, suppose it's denoted by Ke, is given as half I omega square, where this I is the moment of inertia, where I is moment of inertia and omega is your angular velocity. But according to the question, it is given that kinetic energy is equal to theta square. You can say given kinetic energy is k theta square. Therefore, we can equate, let us suppose this equation number 1 and equation number 2. So we can say from equation 1 and equation 2, we get k theta square is equal to half I omega square. From here we can find out the value of omega. So omega square will be equal to 2k theta square divided by I, or we can say our omega will be equal to theta square root of 2k divided by I. So let this be equation number 3. Now the angular acceleration for the disk, if it is given as alpha, so angular acceleration, that is alpha, it is defined as a rate of change of angular velocity with respect to time. Rate of change of angular velocity with respect to time. So we can write that the alpha is equal to d omega and dt, and we are going to introduce a variable theta such that we can write this equation as d omega by d theta and d theta divided by dt. And rate of change of angle, that is theta, is nothing but our angular velocity. So we can write this as d omega by d theta multiplied by omega. And from equation 3, if we differentiate equation 3 with respect to theta, we get d omega by d theta. So differentiating equation 3, we get d omega by d theta is equal to square root of 2k divided by I. Now we are going to substitute this value of d theta in this equation as well as value of omega. Therefore, the angular direction alpha will be equal to square root of 2k I, and omega is given as theta square root of 2k upon I. So this is equal to theta and 2k upon I. Therefore, we get alpha is equal to 2k upon I multiplied by theta. So this is the angular acceleration of disk. This is the angular acceleration of the disk. And we see the option number D is the correct option. You can say option D is correct option. So this completes the question. Thank you.